Okay, guys, you are back at my house. I am running through um, section 4.2, which is simplifying variable expressions. I don't know if you've ever heard you can't combine apples with oranges. They're two different things. Variables are kind of the same way, but we can combine like terms. We're not even going to be solving answers as such. We're just going to be simplifying it and combining like terms. This word right, oops, put it on draw, this term right here, like terms. So you look here, you have 3x and you have minus 7x. Well, those can be combined. So it would be a negative 4x. But and you could combine the 4 and the 9. So you're adding plus, so you're adding a 4 and a 9. And the x squared doesn't have anything to combine it with. But let me see where they give the answer. So we could say x squared equals x times x. Yeah, that's x squared. X is not like terms. So the constant terms are still 4 and 9, and they can be combined. I am right here right now. To simplify a variable expression, we use the distributive property to add the numerical coefficients of like variable terms. So you're just adding the numbers for the variables that are alike. That makes sense. And just the numbers can always be combined because they haven't got anything with them. They're called constants. So the variable part remains unchanged. This is called combining like terms. I went over this a whole bunch in high school. The distributive property. If A, B, and C are real numbers, then A times B plus C equals AB plus AC plus AC, or B plus C times A equals BA plus CA. Just different ways of combining those terms together. By the distributive property, the terms outside the parentheses is multiplied by each term inside the parentheses. So, example down here, number 1, you have 2 times 3 plus 4, which would be 2 times 3 plus 2 times 4. And that would be 2 times 3 would be 6, plus 2 times 4 would be 8. So down here, or we could do 3 plus 4, which would just be 2 times 7 equals 6 plus 8. And your answer is 14. Okay, you can look at number 2 on your own. I want to go on. Pause it if you need to. The distributive property in the form B plus C times A equals BA. You're multiplying the A times the B, A times the C. So it's BA, so it's BA plus CA is used to simplify the variable. Now, we're not solving anything, we are just simplifying again. So, to simplify 2x plus 3x, use the distributive property to add the numerical coefficients of like variables. So you'll see 2x and 3x are the same. So we can pull the 2 and 3 away from the x. We can put the x outside the parentheses over here, and we just say, well, 2 plus 3 is 5. So we would have an answer of 5x. I don't do that very often myself. Usually I just say, well, x and x are equal, or have the same, so I don't split them up. I just go 2x plus 3x is 5x. Whatever you like, though. Okay. How to 1. Okay. Simplify 5y minus 11y. Well, we could take right here it's splitting it up. It's taking the y off and putting it outside the parentheses. And it's saying, well, 5 minus 11 is negative 6. And then you plug the y on. Your answer is negative 6y. I'd pause it and do the next one on your own. Okay. The associative property of addition. If a, b, and c are real numbers, then a plus b plus c minus a plus b plus c. When 3 or more terms are added, the terms can be grouped with parentheses. For example, if in any order the sum is the same, so no matter how you add them up, a plus b plus c, they're all going to be the same. At least as far as that almost looks like a minus. I'm not sure if it's a minus or an equals. Still not sure. It must not have scanned as well as I'd hoped. Let's look down here at example 1. 5 plus 7 plus 15 equals 5 plus 7 plus 15. They're just changing this around. So if we want 5 plus 7, that equals 12. 12 plus 15 equals 27. That equals 5 plus 7 plus 5, 7 plus 15 equals 22. So 5 plus 22 equals 27. It doesn't matter what order you put them in. And yes, I was in high school when I learned these, so you guys are ahead of me. Okay. The commutative property of addition. If a and b are real numbers, then a plus b equals b plus a. It doesn't matter how you turn them with addition. Okay? I don't really care for them adding the parentheses. I realize they do that because it's a negative number and your calculator wants to put negatives around. So 15 plus negative 28 equals negative 13, and negative 28 plus 15 equals negative 13. It doesn't matter. 1 plus 2 equals 3, and 1 plus 2 equals 3, or 2 plus 1 equals 3. That's putting it as the simplest. Now, the addition property of 0. Whenever you add 0 to a number, you're not adding anything to it, so it's always going to be the number you added 0 to. And that is important. I've seen a lot of errors on that. Usually it's just people not thinking, which I do that at times too. Okay, so the inverse property of addition. This is where you have opposites, and that was going back to integers. So you have 8 plus negative 8 equals 0. So when you're adding the opposite, it's going to equal 0. If I were to add 1 million, and then I had plus negative 1 million is always going to equal 0. Oops. I want to know about the news right now. How to 3. Simplify 8x plus 4y minus 8x. Well, you could do like they're doing 8x minus 8x. Or you could do 8 minus 8 and then put the x on the outside. I don't really see that being necessary, but you could. Then you have plus 4y plus y. Well, that plus y, you know that's always going to have a 1 in front of it. Even though they don't show it, there is a 1 when a variable is on its own. Okay, so example 1. I will help you with this, then I'm going to say pause. If you don't want to listen to me, you could hit pause right now so you don't have to listen, but 3x plus 4y minus 10x plus 7y. Well, let's split them apart. We have 4y and 7y. That should be 11. 4 plus 7 is 11, and then you tag the y on. It's 11y, I think. Yes. Then we do 3 minus 10. That should be negative 7. So looking down here at our answer is negative 7x plus 11y. Or you could say 11y minus 7x. That's so. Pause it and do all the answers yourself now. Okay. This one is to simplify a variable expression using the properties of multiplication. So multiplication is very similar to addition. You can times 5 times 6 equals 30. Well, 6 times 5 equals 30. That's not the associative, that's the commutative down here. But the associative, if you take 3 times 5 times 6 equals 3 times 5 times 6. So if you go 3 times 30, it equals 90. If you do 15 times 6, it equals 90. So multiplying numbers. Don't try this with division, though, or subtraction, unless you're adding, which you could be adding a negative. Okay, the multiplication property of 1. Any number times 1 is going to be that number. So if I had 1, 2, 3, 4, 5, 6 dots, and I said I have one group of 6 dots, I'd have 6 dots. And that's basically what it's saying there. The inverse property of multiplication. If a is a real number and a is not equal to 0, then a times 1a equals 1. So 1a is called the reciprocal of 1a. So this one here is saying, let's look down here at example 1. 7 times 1 over 7 equals 1. And this could also be seen as 7 divided by 7 is 1. But when you divide, you multiply by the reciprocal. So this would be 7 over 1. So 7 over 1, 7 times 1 is 7. 1 times 7 is 7, which is 1 whole, because you have all parts of your fraction. So I will let you guys look at this a little bit more. Let's do number 2 together. X times 1 is x. X times 1 would be 1x over x. So it is 1 whole. Okay. Now it does show you on this one, it says x cannot equal 1 or cannot equal 0 though, because you can't divide a number, any number, up into 0 groups. Hope that makes sense. I'm still going over this fast because I'm off school now, so I'm not getting paid for this, but I know you guys need it so that next year we can get you guys high in math. Okay, so pause it and do these. Pause it and do these. Pause it and do these. We're just simplifying fractions, or simplifying variables, variable expressions. Okay. Pause it and do these. I always say pause it and do these because that's one thing nice about math. It's all going to be done basically the same. Let's look at this one. Let's go -5 times 4x, -5 times positive 6. So we are going to go -5 times 4. That should be a -20, and we got to put the x on. Then we're just going to do a plus -30. And they actually didn't do plus -30. They just did -30. That'll work though. Okay. Okay, pause it and do these. Battery savers on. Let's go pause it and do these. Let's go pause it and do these. Let's go pause it and do these. Pause it and complete these problems. Pause it and complete these. Okay, we're on to exercise 4.2. We're on to the exercises, so we are at the end of this section. So pause it and work on these. 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 We're already on to page 265. We've been doing a lot of work. Pause it and work on these. Pause it and work on these. Okay, now we're on to 4.3, translating verbal expressions into variable expressions. This should be fun. Okay, guys, I am going to let you guys go for a while. I will be back. And let's